Hi all, welcome to a short introduction on modern JavaScript. If you are someone who tried learning JavaScript from the internet, there is a very high probability that you have come across seemingly a varied set of program syntax which implements the same logic in multiple ways. You might also have come across terms like callbacks, promises, async await, etc., all of which seems to implement the same thing. This video will try to reduce this confusion and also provide a brief overview of modern JavaScript tools and techniques followed in the industry. First, let us see the evolution of JavaScript across the years. JavaScript, initially developed by Brendan Eich in 1995, started off as a simple scripting language for web pages. It was primarily used for implementing simple form validations and interactions on web pages. The first standardized version of JavaScript was launched in 1997 and was popularly known as ES1 or ECMAScript 1. ES3 or ECMAScript 3, released in 1999, added new features like try-catch and exception handling. ES5 or ECMAScript 5, released in 2009, added upon several more missing features like array methods, JSON support, etc. ES6 or ECMAScript 2015, released in 2015, can be considered as the first modern JavaScript version. Subsequently to ES6, a new release is being released every year, bringing more and more new features into the JavaScript ecosystem. Now, let us go through some of the major new features of modern JavaScript. First one is var vs let difference. Let and constant are new features introduced in ES6 and they provide block scoped variable declarations. This replaces var, which had a functional scoping. To understand this, let us look into this particular example. You can see that in this code provided, the value of x is overwritten to 2, while the value of y remains 1. This is because y is a let variable, which has its scope limited by block, while var has its scope defined by the enclosing function. The second feature will be classes and inheritance. Before ES6, JavaScript used to lack proper classes, but from ES6, it do support classes and inheritance. This can be used for implementing the more familiar object-oriented programming approach. Inheritance is supported by using extends keyword. You can use super keyword to call parent class methods. The next feature is arrow function and this keyword scope. Now, unlike languages like Java, the scope of keyword this is different in JavaScript. In Java, this points to the members of an object, while in JavaScript, this points to the scope of the enclosing function of a given function. This can be better understood by the following example. So, the object obj uses normal functions and the second object obj2 uses arrow functions in it as member. So for the first object, you can see that the value of this dot age is undefined. This is because the scope of this variable is pointing to the parent function of print2, which is the print function. While for the second object, this dot age is correctly pointing to 2000, as scope of this within the when an arrow function is used will be to the main object. The next function is introduction of modules in ES6. So modules allows us to reuse code by writing functionality across multiple files. Before ES6, it was very difficult to provide scope of variable across multiple files, and all the file, and if you import a JavaScript file into another one, it will have shared the same scope. But with the ES6 modules, the scope, we can isolate scope across different files. Now, another feature introduced in modern JavaScript is promises and async await. So this has been primarily introduced to remove a problem which had been affecting traditional JavaScript programming, commonly known as callback hell. It is a situation that arises in asynchronous code execution when multiple nested callbacks are used to handle asynchronous operations. This often occurs in scenarios where asynchronous tasks are depend on the completion of other asynchronous tasks, leading to a deeply nested and difficult to read code. Promises and async await are used to mitigate this issue by writing cleaner code. If you watch the provided example, the callback code is provided on the left hand side and the promise based code is provided on the right hand side. You can see that the nested looping has been completely removed from the right hand side. Since this is a vast topic, we won't be going into the finer details. Learners are encouraged to do a short study on promises to get an in-depth understanding. Now, async await. Async await can be considered as a syntactic sugar to write cleaner code using promises. So, if you watch the provided example, this is the same code written with async await. The LHS shows the callback version and the RHS shows the async await version. So you can see that the flow is written in a sequential manner, which is very similar to programming languages like Java. So here, only after the execution of the first function, fetch data from endpoint 1 and its result is obtained, will the program control logic move to the next line and call fetch data from endpoint 2 function. This is different from the typical JavaScript flow, where if it encounters a asynchronous task, it will continue with the flow of the main program. The typical approach was to write a callback to handle the result returned with another function. So you can see that the code on the right hand side is much cleaner. Again, since this is a much vast topic, learners are encouraged to do further study on this topic. ES6 has also introduced much more features. Some of them are template literals, destructuring assignment, default parameters, spread and rest operators. Then we also have introduced new array methods such as map, filter, reduced, find, etc. So you could go through these topics in your free time. We will move on to the more features of modern JavaScript. So we got a general overview of the language features. Now we will go to the JavaScript framework world. In computer programming, a framework is a foundation over which programmers can build their software. In a similar way, a JavaScript framework provides a base for the convenience of the programmers. JavaScript frameworks are an essential part of modern front-end web development, providing developers with tried and tested tools for building scalable and interactive web applications. Many modern companies use frameworks as a standard part of their tooling, and so many front-end development jobs now require framework experience. The most popular frameworks are React, Angular, and Vue. JavaScript is now used in the server side also. The most popular implementation is Node.js. Node.js enables developers to write high-performance server-side applications using JavaScript. It relies on the V8 JavaScript engine developed by Google. Node.js is extremely popular because of its asynchronous event-driven non-blocking I/O model. This means that Node.js can handle a large number of concurrent connections without blocking the execution of any other code, allowing developers to write scalable and efficient server applications. Now we will go through a brief list of development support tools used by professional JavaScript development teams. These tools help us to reduce errors and also increase code performance. The first tool will be module bundlers. Module bundlers like Webpack, Rollup, and Parcel combine multiple JavaScript files and assets into a single bundle for optimized delivery to the browser. They support features like code splitting, lazy loading, and tree shaking, which improves application performance and reduces load times. Another commonly used tool is called transpilers. Transpilers like Babel enable developers to write modern JavaScript code using the latest language features, and later compile it into older versions of JavaScript supported by all browsers. This ensures that cross-browser compatibility and enables developers to use cutting-edge language features. Babel is a popular transpiler and is used in React. So the next tool commonly used is called a linter. Linters like ESLint and JSHint analyze JavaScript code for potential errors, stylistic inconsistencies, and best practice violations. They help enforce coding standards, improve code quality, and catch bugs early in the development process. Linters can be installed as plugins for coding interactive development environments like Visual Studio Code. Then testing frameworks. Testing frameworks like Jest, Mocha, and Jasmine facilitate the writing and execution of automated tests for JavaScript code. They support unit test, integration test, and end-to-end tests, ensuring code correctness, reliability, and maintainability. In practice, these tests are automatically run before each code deployment to screen out potential bugs. Now, the next commonly used tooling is debugging tools. So debugging tools like Chrome Dev Tools, Firefox Developer Tools, and Node.js Inspector provide powerful debugging capabilities for JavaScript applications. They allow developers to inspect and debug code, analyze performance, and diagnose issues in real time. You can access Chrome Developer Tools using the More Tools option from Chrome menu. The next popular tool is package managers. Package managers like npm and yarn simplify the process of managing project dependencies. They allow developers to easily install, update, and remove third-party libraries and frameworks, as well as manage project configurations. npm hosts millions of packages and is the default package manager for Node.js. If you need to develop a new functionality, chances are very high that somebody has already written a package for the same and uploaded it into npm. You can reuse them and save time. So, since you are working in JavaScript field, you should also be aware of TypeScript. TypeScript is a superscript of JavaScript which adds several more additional features over vanilla JavaScript. It is widely adopted by major projects and organizations. TypeScript extends JavaScript by adding optional static typing along with other features that facilitate the development of large-scale applications. For example, newer versions of Angular are completely written with TypeScript. So in conclusion, JavaScript ecosystem is dynamic and is rapidly evolving. In addition to those mentioned before, many more features are gaining usage, like WebAssembly, which enables us to run assembly code or C++ code along with JavaScript in a browser. Then web workers and worker threads, which support multi-threading with JavaScript, and lots of many more features. Having a continuous learning mindset is imperative to have while working with JavaScript and associated tools. I would encourage all learners to explore and contribute to the dynamic JavaScript ecosystem. I hope you have found the presentation useful. Thank you and see you another time.